Hello, everyone, and welcome to the Esri GeoDev webinar series. We began these webinars as a continuation of the discussions and presentations we've had of developer-related topics between Dev Summits. We wanted to keep the conversations going. We hope you get as much or more out of it than you anticipated. Now, we would like to introduce you to today's webinar, Kickstart Your Cross-Platform Development with Qt and QML. I would now like to introduce Eric Bader, Product Manager for the ArcGIS Runtime SDK for Qt with Esri, and Lucas Danzinger, Senior Product Engineer for the ArcGIS Runtime SDK for Qt with Esri. Eric, let's get started, shall we?
Great, Amy. Thank you very much. Thanks, everyone, for joining us today. Here's what we'll cover for the next hour through this, or the next 45 minutes or so through this webinar. We're going to be talking about building cross-platform native applications today. And so we're going to start off with talking about what the cases are for using native applications and building them. We're going to talk about some of the challenges there as well. We're going to clarify what we mean in this context by the term cross-platform. And then we're going to talk about some cross-platform development technologies that really make this possible. And we'll be talking about QML, some C++, and then of course we'll be talking about the ArcGIS Runtime SDK for Qt for building mapping and location applications cross-platform. It's going to be important for us to communicate to you how you can get started right away building cross-platform applications. And we'll see some real practical use cases presented by Lucas in how you would build once your application and compile it for many different platforms. And of course, a very important part of this is your questions and trying to address those at the end. So let's talk about the case for native apps. I mean, we live in a world of web first, mobile first, which is very powerful paradigm because the browser, lives across all these different devices, and it's a very common and well-tested, tried and true medium for building applications, bringing applications to your users on many different disparate environments. But there are a lot of really strong cases why developers build native applications that run outside of the browser that can directly be integrated with the operating system of the device itself. And so one of these things is applications and their workflows are in a native environment are pretty free to be transient or transition seamlessly from connected to disconnected environments. So your workflows can work online and offline or transition from one to the other pretty easily. Another really compelling reason for building native applications is your apps have direct native access to the services and sensors provided by that device, right? And so you have direct access to things like Bluetooth networks. Of course, one of the most important things right here within the context we're talking about is your GPS and your location information that device provides. The ability to orient the device using the gyroscope of the device itself, and of course, accessing the file system on that device. It's pretty well known that the best possible performance you can get is within a native application running as close to the bare metal of the device itself. And that gives your users the most seamless, smooth, delightful user experience that you can give to your users. And of course, the importance of being able to share these through common native application ecosystems through app stores and marketplaces. And of course, native applications too can talk to other native applications that are most commonly found on those devices. So there are a lot of good, strong reasons for going native. So now we get to the challenges, and I think these are pretty well-known challenges, right? So many different platforms out there that your users are using to use your applications, right? There's Windows, Android, Mac OS, Linux, iOS, and of course, let's lay on top of that challenge the many different devices that run on those platforms, right? You've got the Galaxies, you have the iPhones, iPads, Windows desktops, Surface Pros. And then, of course, now you're going to think, all right, my users are using all of these platforms and devices. What's the best development pattern and paradigm for addressing my user base across this wide range? And of course, you've got to choose. Are you going to use .NET? Do you write your code in Objective-C? What are the limitations? Are all of my users going to be able to access those applications? So you can see kind of an overlay of many different layers of challenges when you're building cross-platform apps, right? So enter Qt or Qt. What is Qt? Well, Qt is a cross-platform C++ SDK for developers, a great software, powerful software package and library created and developed and sponsored by the Qt company itself. And it's been addressing, Qt has been addressing this dilemma of cross-platform for a number of years now, right? Back in the day when you just had Windows and Unix, they started trying to solve this paradigm to have a GUI experience that would run on multiple platforms. So it is by nature a cross-platform application framework and widget toolkit. It was designed for this in mind. It's today, there are a number of different toolkits out there for building C++ applications. This is arguably the world's most popular GUI framework for the C++ native app community. It was designed with cross-platform in mind back in the 90s. So it's been around a very long time, and Esri's got a very strong partnership with the Qt company as well. So we'll see going forward. It's extremely approachable in nature. In other words, it addresses the user interface designer approach as well as the hardcore C++ developer. So it's approachable to many different developer audiences. It's open sourced as well. So this is very important because Esri is a contributor to the open source project, the Qt project. So it's both commercially available and open source. And Esri, being a contributor, has developed a GeoServices plugin that plugs into the Qt framework in its Qt nature, and it's approachable to Qt developers that don't know a lot about Esri technology and Esri APIs. They can quickly get mapping into their application in their environment. It's a great on-ramp for them to learn Esri and the power of ArcGIS. So why do developers use Qt? Well, for many of the same reasons that I talked about the case for building native applications. Great performance, close to the metal, C++, close to the operating system and the device resources, GPU, CPU. It provides the framework for you to not have to worry about accessing those low-level services and sensors on the device. You can access the hardware and the storage of the device through the Qt framework, and it handles a lot of the complexities of that for you. It allows the developer to write once and deploy and build to many different devices, whether those are running on Windows, Linux, Android, iOS, or Mac OS. So it's very powerful in its ability to allow you, the developer, to focus on your application building and not worry about what this application is going to look like on an iOS device or an Android device or on Linux or on Windows. It's going to allow you to just focus on that business logic, and it handles the user experience very well for you. But it's also very attractive to the web developer community because, as you'll see as we go through, it provides a QML language, a very declarative language for designing very responsive, delightful user experiences. And it has a JavaScript backend, and it embeds a JavaScript engine for you to run JavaScript business logic natively on the device. So Esri provides a complete mapping, geospatial, and location SDK that is built and extends on top of that Qt framework. And this is called the ArcGIS Runtime SDK for Qt product. And it provides APIs and resources for building world-class mapping and location-aware applications for any device, leveraging the power of Qt underneath. And of course, now it brings the power of ArcGIS to this developer community and allowing users to visualize their data in the geographic context through maps, 3D views, data layers, and graphics, giving the developer control over how the symbology is representing those features and how the data is rendered on the device. It also allows users to interactively select their own geographic information, select their own data, query it, see it visualized on the map, highlight features and map elements, and display those query results in nice, readable, pleasant to the user pop-ups. It also allows users to create maps, author maps using the API for the ArcGIS platform, and then share them with others across that entire ArcGIS platform. A key feature of the ArcGIS Runtime is its ability to write applications that utilize offline capabilities, working with data and maps in a completely disconnected or connected environment. But a disconnected environment in a lot of cases is extremely important to people out in the field. As updates to data and maps are made in your application in an offline context, the API then supports the synchronization of these updates back to the connected cloud. So it keeps your workflows and your enterprise in sync. So it's very powerful in that way. The API is designed to be completely asynchronous. This is important too for great user experiences as your workflows continue, your users continue to work while access to resources and other information it may take some time to load, right? So your experience remains uninterrupted or blocked. And there are many more powerful geospatial capabilities available that are common across all of the ArcGIS client APIs. The runtime provides that. And you can find out a lot more about ArcGIS Runtime SDK for Qt, and we'll see this throughout the presentation on developers.arcgis.com/Qt. What are some of the other ways that Esri is using this powerful Qt technology? Well, as we're going to talk about, the ArcGIS Runtime SDK for Qt is a developer API for building great, rich, out-of-browser native applications for many different devices. But also a very popular product here at Esri is App Studio for ArcGIS. App Studio for ArcGIS is completely built on top of the ArcGIS Runtime SDK for Qt, which is built on the Qt framework. But this is a powerful tool for non-developers to be able to build applications for all 5 platforms without having to write a single line of code. So this is very powerful for the casual or non-developer community as well. Survey 123, arguably one of the most popular apps from Esri, and it targets the data collector who uses form-based types of data collections in the field. It's completely built and powered by the Qt SDK also. And of course, being a very powerful C++ library as well, our runtime core uses it for many of its test beds and testing before releases and during the release cycles. It's very powerful and widely used within our testing frameworks. So let's see how the ArcGIS Runtime SDK is taking advantage of the power of Qt. Qt gives developers a clean separation of the model and view components for their applications, and Esri takes full advantage of this with the ArcGIS Runtime API. So the ArcGIS Runtime API is modeled in both of these, the view components and the model components. QML renders the view for very modern looking user experiences. It's very declarative language, very approachable, very easy to read, and we'll talk a little bit more about this. But the Runtime API is modeled in both QML as well as completely modeled in C++ for Qt. And for cross-platform development, the framework that leverages QML is called Qt Quick. And so you can build ArcGIS Runtime SDK applications using the Qt Quick framework for just building everything in QML if you want, or you can use QML to be the strength of the view and use the C++ backend to be the power of your business logic. the Qt SDK provides a Qt widget experience as well for GUI developers, and Esri provides its APIs through the Qt widget model as well. And this is used for building desktop applications, Windows or Linux. So let's take a quick, pardon the pun, a quick look at the simplicity of what QML is. So QML is a declarative language for building great user experiences that go across many different platforms. It's extremely powerful, as you'll see. So it's intuitive to look at because many of us are very familiar with the JSON structure and cascading style sheet paradigm as well, and HTML5, and that's what this language is modeled for, right? So it's highly readable as JSON. It also provides a widget toolkit with many different types of UI elements, such as buttons and text boxes and all the things, scroll bars, and all of the things that you would expect in a user interface toolkit. So the very declarative UI with or UI elements that have properties that you can set. In this case, this button is anchored to a position in the rectangle, which acts as the window in a particular position, so you can handle that through properties. But also very, very powerful, and this is very key for web developers who are looking to build just purely native applications. QML uses JavaScript to handle a lot of its events, all the types of actions that might take place on one of these elements here. And as you can see, it's JavaScript, and as you can see here too, the types from the ArcGIS Runtime are exposed in this QML JavaScript model as well. And in this case, you know, when this button is clicked, it's going to change the map view's camera and viewpoint characteristics. QML also provides this notion of dynamic property binding, which also is extremely powerful, right? In this case, for example, the button's appearance is going to change based on the condition of another type within this QML program, right? When the map's load status is loaded, then the button is going to appear enabled. If it's not, then it's going to appear disabled. And of course, extremely important here is that Esri has extended the type model in QML to expose objects as these JSON structures. So in this case, we'll see that this rectangle window has a map view in it, which has a child of map, which has a property for ID, so you can hook into it and access it from other parts of the program. But then that map also has a simple base map layer in it. So this is a complete program that compile and run, and Lucas is going to show us this in action. But you can see the simplicity of QML. And there are a few tips that we'd probably recommend here. With respect to using QML and C++ with respect to the ArcGIS Runtime. The ArcGIS Runtime for SDK for Qt is one SDK, but it provides two APIs, as I mentioned. An API that's completely exposed in QML and one that's completely exposed in C++. They're functionally equivalent. So this is important to note that since they're functionally equivalent, you typically write your application either in QML or you write it in C++. Now, you can use QML to be the front end of your application and then use the ArcGIS C++ API in the back, and that is a very common pattern to use. It's important to note also that JavaScript skills come in quite handy in the QML tier. So you can write all your business logic in JavaScript if your applications are all in QML. However, the more you load up in that JavaScript tier, you're in the view tier. So it's important to keep a balance of just how much heavy lifting you do in that. But you've got flexibility. So this is very important to keep in mind. And of course, if your applications are going to do some GIS heavy intensive types of application logic, your C++ API backend is the way to go. Great. I've done a lot of talking about the context of what we're talking about here, but the most important thing here is going to be a good practical way to see this in action. I'm going to hand that over to Lucas to take us through that. Lucas?
Great, thanks, Eric. So now that you've learned a little bit about what Qt is and what the ArcGIS Runtime SDK for Qt is, I'm going to talk to you about how to actually set up your development environment so you can start building your application and deploying it to all the different platforms that you want to support. Now, an important thing to know when you're building a Qt application is that there's many different host machines that you are going to work on. And depending on the host machine that you're working on, there's different platforms that you can deploy to. So for example, if I'm building on my Windows machine, I can compile and deploy out to Windows or to Android. If I'm working on a Mac machine, I can compile and deploy out to iOS, Mac, or Android. And if I'm working on a Linux machine, I can compile and deploy to Linux or Android. So note here that I can't, for example, deploy to iOS from Linux, or I can't deploy to Linux from Windows. This is because the underlying SDKs and compilers that are needed to build and deploy to those platforms are only supported on certain host machines. But the important thing to know is that you can share your code. So while I can't actually build on each individual host machine for every single platform, I can write my application on one platform, share the code onto the other development platforms, and deploy out from there. So that's a little bit about the development machines, but what do you actually need to install on each of those machines so that you can perform your cross-platform development tasks? The first thing that you're going to need is the compiler and the native SDKs for the target platform that you're working with. On top of that, you'll install the Qt framework. And the Qt framework is what's going to provide you that abstraction layer so you can write your code just against Qt, and then Qt hooks into the compilers and the SDKs for all of the different platforms and figures out all of the differences for you. And on top of that, if you want to develop GIS applications, you'll install the Runtime SDK for Qt. So let's dive into each of those. For compilers, if you're developing on Windows, you'll need to first install the Microsoft Visual Studio C++ compiler. Runtime currently requires the 2017 compiler. In addition, if you're accessing online secured resources, you'll need the OpenSSL libraries, which you can either get the pre-built binaries from somewhere online, or you can pull down the source and build yourself. If you're developing for Android, you'll need a few different items. The first is the Android SDK, which comes from Google. You'll also need the JDK, and you'll need the NDK. And the NDK is what allows Android to utilize the C++ code that's coming from Qt to build native applications, as Android is typically written with Java. The NDK currently uses GCC for the compiler, but is soon moving to Clang for the compiler. Additionally, you'll need OpenSSL for accessing any online secured resources. For Linux, you'll simply need the GCC compiler, and again, OpenSSL. For iOS, you'll need to install Xcode, which will give you access to the Clang compiler, and it will also give you access to the various command line build tools that Xcode provides. You'll also need to join the Apple Developer Program, which will give you access to provisioning your devices for testing, so you can actually build your applications and deploy out those applications to your various test devices. And finally, for Mac, you'll need to also install Xcode, so you get access to Clang and the build tools, and you'll need to join the developer program. So the important thing to note here is that these are the underlying dependencies that Qt has. You need to have these installed on your development machine in order to build your applications. But you, as a Qt developer, don't need to know how to work with each of these individual items. Qt will work with these things for you. So don't get overwhelmed by the amount of installation steps that you need to do. So once you've installed those compilers and the underlying SDKs, you'll now need to install the Qt framework. You can get the latest Qt SDK from qt.io. Now, Esri is actually a reseller of Qt. So if you want to access Qt and buy a license, you can actually contact us and we can get you a good price on a Qt license. Once you've downloaded the latest Qt SDK, you're going to want to run the installer. And in the installer, you'll select your desired kit. Now, the kit is Qt's way of referring to the desired platform that you want to build for. It consists of some things like the compiler and the debugger. So for example, if I'm running the Mac installer, you can see here under Qt.5.10, Qt 5.10.0, we have 4 different kits available. We have Android ARM v7, Android x86, iOS, and macOS. So when you're running the installer, think about the platforms that you want to support and check the checkboxes next to the ones that you want. In this case, ARM v7, Android ARM v7 is typically what most Android devices are running. They're running ARM processors. Android x86 is typically used for testing on Android emulators, and iOS is for iOS development, and macOS is for macOS development. On Windows, you'll see a similar experience, but you'll see different kits available. In this case, we've selected MSVC 2017, which is the Microsoft Visual C++ compiler, 2017 64-bit, and we've also selected Android x86, Android ARM v7. On Linux, we selected GCC 64-bit, which will give us access to building Linux desktop applications. And again, we've selected Android x86, Android ARM v7. So at this point, you've installed the underlying compilers and the SDKs, and you've installed the Qt framework. So you're actually ready to start building Qt applications. But if you want to actually build a GIS application, something that brings spatial and location information into your application, you'll want to install the ArcGIS Runtime SDK. First thing you'll do is sign up or sign into the developer site, and that is at developers.arcgis.com. If you haven't already, you can create a free developer account there, and that'll give you access to all of the different SDKs that we have. If you go to the download section, you'll see several different options available, and this goes back to the slide earlier where I talked about the different development host machines. We have Windows, Linux, and Mac, so think about which platforms you want to target and download the appropriate version of the Runtime SDK for Qt. Once you've downloaded it, you'll want to run the installer. And once the installer completes, it'll automatically launch the post installer. And the post installer is a tool that we wrote that helps integrate the SDK bits that we lie down with the underlying Qt framework and the Qt Creator IDE. This will give you things like help and templates integrated right into Qt Creator for you. So that's a lot of information, but just keep in mind, all you need is the compiler, the SDK for the target platform, the Qt framework, and the ArcGIS Runtime SDK for Qt. And also keep in mind that Qt abstraction makes it simple. So once you've installed everything, you don't need to know about the platform-specific concepts. There's no platform-specific code necessary, meaning your same source code will build on any of your development machines. So a pro tip, and something that we do at Esri on our development team, is we set up development environments on Linux, Windows, and Mac. And all of our devs, we typically develop on our platform of choice. Some of us like using Linux, some of us like using Mac or Windows. Develop on whatever you like to do, and run daily builds on each platform through Jenkins or some other continuous integration system. And this will help you get daily builds of your application so that you can test on all of the different platforms, but you don't have to be disrupted by jumping between different machines and performing builds on all of the different host machines. All this information is available on the developer site. For install guides, we have Windows, Linux, and Mac. So now that I've talked about how to set up your development machines, I'm going to walk you through how to create your first application. So this is Qt Creator. Qt Creator is the IDE that comes with the Qt framework, and it's the preferred IDE when you're building cross-platform Qt applications. You can see that it has things like examples built right into it, and tutorials and help. But I'm going to go to projects and select new project. There's several different templates available. Here are some Qt templates. Here is if you want to build a library or some unit tests or C or C++ applications. But you'll notice there's an ArcGIS project template here. And there's actually 3 different options available. The first is the Qt Widgets app. And this goes back to what Eric was talking about earlier. Qt Widgets is our desktop framework. So if you want to build an application that's going to target desktops only, Windows, Mac, and Linux, you can consider using Qt Widgets. We also have Qt Quick C++ applications, and this is for building cross-platform applications. Your UI will be written in QML, but your backend will be written in C++. And finally, we have Qt Quick QML applications. And this is similar to the previous option, only your business logic will actually be written in JavaScript code. So when you need to handle events, once something completes, you'll write JavaScript instead of C++ code. For this demonstration, I'm going to select Qt Quick QML app. So the first thing you'll need to do is give it a name. On the second page, you can give it a description. You can select if it's a 3D or a 2D application. By default, it's 2D. And you can also change the base map that we use. I'm going to go ahead and select 3D, and you'll see there's one more option that becomes available when it's a 3D application. I can select the surface that's being used. So in this case, I'm going to select the terrain 3D, but I could also select the topo bathymetry 3D. And I'll go ahead and change the base map to streets, and I'll hit continue. Here's the kit selection page, and this goes back to when I was talking about the installer. When you install on your system, you have various kits that you can install. And once you run a project wizard, you'll see the different kits that you've installed available. So in this case, I've got Android ARM v7, Android x86, Desktop 592 Clang, which is for Mac OS, iOS, and iOS Simulator. In this case, I'm going to select all of them because I want this application to be run on all these different platforms. I'll hit continue, and the last page allows you to add it to source control if you like. So the template will create some stubbed out code for you based on the options that you selected in the wizard. The first bit of code is the import statements. Next, you'll see the application window, and this is just defining the outer window of the application. Inside of that, we have a scene view that fills up the entire window. And inside of the scene view, we have a scene. Think of a scene as a 3D map. The scene contains a base map, in this case, the streets base map. And the scene also contains a surface, and this is what's going to give us the realistic 3D elevation. Okay, so in the bottom left here, I can select this option here to show me the various kits that I have available to build this application. I'll select desktop, and I'm going to select release. I like building in release because it builds a bit faster and runs a bit faster. And then if I need to debug, I'll switch over to debug mode. I'll press the play button, and this is going to compile the application and launch it. So here I've got a 3D application running natively on my Mac, and it's got, if I zoom in here to some more mountainous areas, you can see that I've got some nice terrain streaming in as well. Okay, so what if I wanted to deploy this out to a different device? Let's say I wanted to deploy it to Android. Well, I'd go down here to my kit selection and select Android ARM v7, and I'll select release. And once I've done that, it'll enable the play button again. So I'm going to hit that play button to run it. And I'll get a list of compatible devices available to me. In this case, I've got an actual Android device, and I also have a couple of emulators available. So I'll get that build started, go to the compile output, and we can watch a little bit what's happening here. This is taking this Qt project and utilizing all those different bits that we installed earlier, the Android SDK, the JDK, and the NDK. It's using all those tools to actually build an Android executable. Once the build is successful, it's going to utilize some other tools from the Android SDK, such as ADB, the Android Debugging Bridge, to actually build an APK. An APK is an Android package. And think of it as basically a zip file that contains the executable and all the dependencies that it needs. Once that APK is built, it deploys it out onto my device, and I can then run that application on my device. I'm connecting to my device here, and you can see I've got the streets 3D base map. Okay, so how about if I wanted to run that on iOS? If I go over to the kit selection, I can see that there's iOS and iOS simulator. In this case, I'm going to select the simulator. I'm going to select release. I'll go ahead and hit play. And this is going to do the same thing as what Android's doing, only it's going to be using Xcode and the various tools that we get with the Xcode installation to build and deploy an iOS application to my simulator. Now the simulator is a tool that comes with the Xcode install, and it's really handy because you can select various different devices. You can, for example, use iPhone X or iPhone 5, 6, 7, or the Plus editions. You can do iPads and so on. So it's a really nice tool to be able to test many different form factors. You can see here my application's installing and it's launching. And shortly you will see the 3D globe. Now they're not the emulators and the simulators for Android and iOS aren't the fastest, but they're great for testing on different form factors, so you can quickly see what that application will look like on that device. So that's great, but most of us probably want to do more than show a map or a scene with a base map in it. So as a developer, what are your resources for you? Where do you go next? The first place I'd recommend going is the developers site, developers.arcgis.com. On the main page, you can select the Qt icon here, and this will take you to the Qt landing page. We have several different resources for developers, and each has a distinct purpose. The guide is the place that you come to get conceptual information. So if you want to understand 2D or 3D maps or geometry or feature services, the guide will help explain that information to you. Once you understand the concepts but want to drill down to a specific class, you'll want to look at the API reference. This will tell you all of the information you need to know about the individual API calls. The API reference is also integrated with Qt Creator, so you can access this directly from Qt. And next are the samples. We provide samples that are basically mini applications that show how to do some workflow. We provide them for both QML and for C++. We provide them on GitHub so you can build them yourselves, or you can run the sample viewers. So you can download the sample viewer, or if you install the SDK, you'll get the sample viewer installed automatically. Now the other great tool that we have, and this is a bit newer, is DevLabs. If you go to the main developer site and go to the Start Developing Your App section, you can explore the DevLabs. And DevLabs are tutorials that help you understand how to build up your data and how to code up your application to utilize the data that you've created. If you go to the Browse section, you can filter by Qt and see the DevLabs that are applicable for Qt. Now we're always looking to add more of these, so there should be more very shortly. This is the sample viewer that's installed with the SDK. When it launches, it displays just the first sample, which in this case is the change base map sample. I can select different base maps, for example, imagery or oceans. And the nice thing is that in the top right, if I select the menu option, I can then select source code and see all of the code that powers the sample. This is a pretty nice tool for you to use as developers because you can find a sample that does the workflow you want to do, see the code that powers it, and actually copy that code right into your application. There are lots of cool samples in this application. For example, if you go to analysis, we've got some really neat 3D analysis, for example, line of sight. We also have viewshed and some different querying options. Okay, let me restart my sample app. So for example, on the line of sight application, this answers the question of if a target can be seen from a given observer location. So for example, as I click around the scene, I can see when it's cyan, it's visible, and when it's magenta, it's not visible. So that's a pretty cool example of how to perform a line of sight analysis. And I can see, again, see the code that powers that application. Now let's say for my application, I want to add a shapefile to my sample, something really basic. Well, this example here shows a point shapefile and a vector base map. So I'll go to the source code, I'll copy the code, I'll go down here to my kit selection. I'm going to build on Mac just to make it a bit faster. Now the code here is pretty simple. We've got a data path set up to point to a shapefile directory. Now we've switched over from a scene view to a map view, and so that means we have a map inside of it. This time we're using the streets vector base map instead of the raster base map. And inside of the map we also have a feature layer that uses a shapefile feature table pointing to this shapefile. Once that feature layer loads, we're going to set the viewpoint of the map to be the full extent of the shapefile. So go ahead and hit play, and this is going to build the application and consume that shapefile in runtime. So that's just an example of how you can get set up using our install guides, and then how to utilize the different SDK components to actually build up an application and deploy out into many different devices. Now in this case, I only showed Mac, iOS, and Android, but if I wanted to build for Linux and Windows, I could simply share this code onto those development machines and build and run from there. So with that, I'll hand it back to Eric.
Great, Lucas. Thank you very much. So let me just underscore what Lucas just took us through, right? Developers.arcgis.com. that is your headquarters for all things ArcGIS developer. And so the next step for you would be to go to our developers.arcgis.com site and sign up for a free developer subscription to our program. And then with that subscription, you get lots of bells and whistles, but you get access to all of the tools and the SDKs at all levels to go ahead and build and utilize within your organization and plan your deployments. Read the guide, the fundamental topics in the guide. So there's great tutorials and resources in the guide on developers.arcgis.com/Qt to go through and help you understand and get your hands dirty on exactly what we've been talking about today. And of course, don't forget the dev labs that Lucas mentioned and showed you. These are great resources. They only take like 10 to 15 minutes per lab for you to get started on the workflows, how you get your data ready for cross-platform development, how you build your applications, great resources, and we'll continue to grow those. There's almost 100 of those out there right now. So we invite you to study and modify the samples. They're open source. They're available on github.com/esri/ArcGIS Runtime Samples Qt. Go ahead and take those, download them, play with them, use them, contribute back to them, communicate with the team about them, and give us feedback. And of course, the most important thing in building community with you guys and with our development teams is the use of GeoNet. So if you communicate with us on the GeoNet forum for Qt. This is a place where you get blogs, you get communication with the development team, you share ideas and share your communication with many different folks in the development. GeoNet, our community forum. So let's just recap what we've gone through today. So Qt is designed for cross-platform, and Esri leverages that cross-platform strategy from Qt with a very strong business partnership and also technology that we go to market with together. And ArcGIS Runtime SDK for Qt extends that cross-platform nature for Qt, and so ArcGIS developers can get started right away. You don't have to be a C++ developer to build great-looking cross-platform runtime applications. QML and Qt Quick provides a fantastic framework for reaching a very common web developer community for building native applications. And we've seen the many products that Esri leverages with respect to the Qt SDK for cross-platform in a lot of different ways. So with that, I want to thank you for your attention today. Thank you for joining us. I'm going to hand this back over to Amy. Amy?
Thank you, Eric. We're now going to begin answering the questions submitted during today's presentation. We received quite a few, and we will try to get through as many as possible, but whatever we do not get to today, we will address in a GeoNet blog post after this webinar. As a reminder, you can still submit questions through the questions pane in your attendee control panel. Our first question is, why would we use Qt QML instead of the ArcGIS Runtime SDK for .NET along with Xamarin?
Great question. Thank you for that. It's totally answerable by you or by the developer who's looking to choose a cross-platform strategy. If you are a natural C# .NET developer, you would probably be inclined to look at the great cross-platform capabilities that are there within the ArcGIS Runtime SDK for .NET, right? So that's a very good question. If you're more of a, not so much in the .NET camp, but you're used to other technologies such as web development, maybe JavaScript or C++, you would probably naturally look more toward the ArcGIS Runtime SDK for Qt. It's completely up to you and with, dependent on the resources you have for your organization and the developer profile of your staff there in your organization. If you need to reach all 5 platforms, the ArcGIS Runtime SDK for Qt is your option. If you're primarily targeting 2, maybe 3 platforms, then you've got a choice to make there. So, Lucas, do you have anything to add to that, or maybe not?
The only other thing I would say is there's a bit of a difference in your coding practice, in the sense that Xamarin allows you to share your backend code, but much of your UI is typically a bit more tailored to the platform you're supporting, whereas Qt's much more of a write once, deploy anywhere. So there's benefits and trade-offs of that. Not one of them is not better, but they're different. So that would be the only other addition I would have to what you said.
Yeah, great point.
Okay, next question. Aren't Java and JavaScript supposed to be cross-platform? What are the advantages of Qt over those two?
Another great question. So there's lots of technologies out there that can do cross-platform, and they have their strengths and weaknesses. So yes, Java is designed for cross-platform, and Esri's ArcGIS Runtime SDK for Java does work for building once and deploying to Linux, Windows, or Mac OS. JavaScript, yes, is supposed to be a cross-browser language to use. It's very powerful for cross browsers, and there are many browsers for many different devices, from desktops to all the way to mobile devices. Sure, so it's going to depend on your user base and your ability to go to market quickly with the development skills that you have at your disposal. But yes, those that you mentioned, Java and JavaScript, they are cross-platform as well. So what would be the advantage of using Qt over those? It's just going to, I don't know if there's any one thing that stands out, but you certainly have a flexibility of choices in language, right? You can be a JavaScript developer and build native apps using Qt. You can, be a wizard at JSON structures and utilize QML, and you can really get probably the best possible performance you possibly can in cross-platform, putting a lot of your business logic in C++, and that runs pretty much as close as you can possibly get to the bare metal of the device. That's all I would really say there.
Okay, great. Next question, number 3. I don't know C++. Is there any other option to build the backend other than using C++?
Again, I'll take that. Well, if you're going to use the ArcGIS Runtime SDK for Qt, that is a C++ toolkit in and of itself. So you would utilize C++ using that. But the ArcGIS Runtime gives flavors for many different platforms: Java, Mac OS, iOS, Android. So you've got lots of flexibility if you're looking across the entire ArcGIS suite of SDKs. Lucas, do you have anything to add to that?
The only thing would be you can utilize the Qt Quick and QML paradigm, which I demoed, and that was all using QML. So instead of writing C++ in my backend, I would write, for example, when the load status changed, once it was loaded, I set the viewpoint of the map view. That was all in JavaScript code. So you do have, within the Runtime SDK for Qt, you have the option to pretty much write everything in QML and JavaScript. So that is an option for you. You'll sometimes have to likely dive into C++ code if you want to do something that's particularly intensive, because typically the JavaScript code that you're running is on the UI thread, and you can start to hang up your applications if you're doing some pretty intense things on the UI thread.
Okay. How can we write an app that can be built for both iOS and Android platforms?
Okay, great question. So native applications that run on both iOS and Android, you could utilize the ArcGIS Runtime SDK for Qt or the ArcGIS Runtime SDK for .NET. which has Xamarin technology in it. So either one of those choices will address that write once compile for iOS and Android. Lucas?
Right, and once you've installed the underlying bits that you need, like I showed in my demo, you can select your kit that you want to deploy to, and without any code changes, actually just deploy out by hitting the run button and selecting the device you want to deploy to.
So yeah, so you don't have to be knowledgeable in Swift or Objective-C or Java Android or Kotlin, because the underlying framework of Qt, as Lucas said, has the kits that handle all of the particulars about deployment and runtime for you when you choose a kit and just tell Qt Creator to build it. And it handles all of the packaging and building for that specific target for you. So you don't have to, if you know QML well enough, as Lucas showed you, you can just take that and build for all 5 platforms. But if you're just using those 2, you can just use those 2, and you don't have to know anything about those programming languages.
Okay, and then last question. With the power of the App Studio ability to build these apps for all the platforms, has Esri thought about providing the build environments as a VM or container service for other people to use? If not, what are the challenges that we may find for our company's own common build environments?
Great question. So what App Studio can do today is do a cloud make. In other words, you don't have to have the builders on your device. So basically, App Studio by default, when you build an application or you tell the app to build your application for you, it'll compile off premise on the cloud make, which are hosted VMs, to do that compilation and give you back the results of that compilation. So that happens. We have looked at that for ArcGIS Runtime SDK as well for Qt, and we still talk about that and consider we're considering some of those things. But I hope I answered that question. Lucas, do you have anything?
I would just say that that's one of the benefits, or one of the reasons for using App Studio, is that you get access to this cloud make system. But the tip that I provided, where you set up your own build machines, that's essentially what cloud make is, and you can do it at your own scale within your organization as well. So run the install steps on a Linux, Windows, and Mac machine. Set the jobs up in Jenkins or some other CI system, and just have those kick off daily, and you can access the outputs just in a very similar manner. So I'm not sure if we'll ever get to exposing the actual underlying App Studio Cloud Make to everybody, but if you want to use App Studio, much of the information we shared here is applicable to that, and also you can kind of create your own Cloud Make.
Okay. Well, thank you very much. Thank you, Eric and Lucas, and thank you everyone for attending today's webinar, Kickstart Your Cross-Platform Development with Qt and QML. Remember, if we did not get to your question, we will be sure to address them in the GeoNet blog post after this webinar. On behalf of Esri and our presenters, thank you so very much for joining us today, and have a great rest of your day.